Okay, let's now look at some sequences and see if we can write a formula for the nth term based on the pattern that we have going, okay? So this is going to take some thinking and some creativity on our part. So first one is A, 1, 1/3, 1/9, 1/27th, okay? So it looks like we're going to want to call this A sub n. Okay, we're looking for a formula for the nth term just based on n. And we're not going to write a recursive formula this time. We're not going to base it on the term before. If we did, that might be a little easier because we would just be dividing by 3 each time, right? So that's a little easier way to write it. But we need to be able to write it based on based on n, the term and the sequence, and then we'll have a better formula then. So the first term is 1, not very helpful. The second term is 1/3, okay? So, and then the next term, it looks like that would be 3 squared, right? Because it's divided by 3 and then divided by 3 again, but really that's 3 times 3, 9. And then 27 you could think of as 3 cubed, and 81 you could think of as 3 to the 4th, right? So this is definitely a 1 over, and then we definitely have 3's going on. This is 3 to the 1st. This 1 could be 3 to the 0, because remember that's 1, so that's cool. This is, oh, so this is 3 to the 0. This is 3 squared. This is 3 cubed, okay? So it's 3 to the, and let's see, is it to the nth? No, because this is 3 to the 1st, but it's the second term, right? This is n equals 2. Let me change colors here. So this is n equals 2. This is n equals 1, n equals 3, etc. So notice that when it's the third term, it's actually 3 squared. So our formula must be n minus 1, right? And just see if that works for all the terms that you have, and then you're probably good to go. So 1 over 81 is 1 over 3 to the 4th. And yes, that is the 5th term. Okay? All right, next we have 1, 3, 5, 7. Hey, we have the odd numbers. Okay? So let's see, we're looking for B to B sub n. Okay, so first of all, we're starting with 1, and then it looks like we're adding 2 each time. So let's see, +2, +2, and +2. And let's see, from the first to the second term, we're adding, in the second term, we're adding 2 once. So we did a problem that was kind of similar to this before. We did 1 plus, that's just the first term, plus 2 times n minus 1, right? Because on the second term, you've added 2 only once. On the third term, 1, 2, you've added 2 twice. Okay, so this would be a good formula. Sometimes what you're going to see, if you see a different answer, it's because it's simplified a little bit. So I'll just simplify that so you can see. So this is 1 plus 2n minus 2. So b sub n is 2n minus 1. Okay, this answer is actually totally fine, but this answer is also good. Okay, same thing, just simplified a little bit. All right, let's see if we have any space for the next one. I'll just change colors here so we can tell which problem it is. All right, 1, 4, 9, 16. Looks like they're squared, right? So let's see, this is 1 squared. This is 2 squared. This is 3 squared. This is 4 squared, and this is 5 squared. Now I want to know, is it n that's squared, or is it n minus 1, or n plus 1, or what? So let's see. This is n equals 1. This is the second term, n equals 2, n equals 3, 4, etc. Okay, great. So look, when n equals 5, 5 is squared. So our formula, let's call it c sub n, is just going to be n squared. Okay. Okay, for the last one, I'm seeing a lot going on here. First of all, I'm dividing by something, right? And secondly, my sign is changing positive and negative. So I gotta multiply by something maybe to make it positives, change positives and negatives. All right, so let's call this d sub n and the d sub nth term. So let's see. First of all, this is like 1 over n, isn't it? 1 over 2, 1 over 3, because this is n equals 1, this is n equals 2. So, and then we have 1/2 here. This is n equals 3, and we have 1/3. So I definitely want to have 1 over n in my answer, because that's where I'm getting the fraction part. Now, to get the negatives, I need to multiply. How do you get something to go negative, positive, negative, positive? You multiply by -1. Okay, so if I multiply by -1 though, let's see if that works, because 1 over, for the first term, 1 over 1 is 1, but then that would be times -1, and this one was positive. I actually need the second term to be negative. So I probably need to do, raise it not to the nth, because that would be 1 over 1 to the -1 times to the first power. So that would be negative there. I don't want to do n minus 1, I don't think, because then the first term won't work. Because then that would be 1 minus 1, that'd be to the 0 power, and anything to the 0 power, oh, that could work actually. Anything to the 0 power is 1 instead of -1. So then, yeah, that would work. But then let's see if that works for the second one. So for n equals 2, that's 2 minus 1, so that's to the first power. Oh, that's fine. Okay. N equals 3, that would be -1 squared. Okay, which is why that one is positive again. Okay, so I'm happy with that. N minus 1. The book's answer has n plus 1, which would also work. But it turns out n minus 1 works too, and I checked it on those terms. Okay, so that was a little bit more complicated one, but remember, you could always like kind of separate out what's happening in the formula.